Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 45, Bonding Part 5. Here are our objectives for today's video. Pause here. I would include the drawings. You don't need to label the 109.5 degree bond angle on the one to the left. All right, so this was the video I was actually most nervous about making once I learned we were doing online learning because there's a lot of drawing involved. So if you're feeling a little bit confused about the drawing, we're going to do our best to address that during class. I don't have like a great drawing tool on my computer, but we'll do our best to get through all the drawings that you need. So the first geometry we're going to address today is the tetrahedral geometry. So that's when you have 4 areas of electron density. The bond angles are going to be 109.5 degrees. If you have 4 bonds, 0 lone pairs, the shape is also tetrahedral. When you've got 3 bonds, 1 lone pair, the shape is trigonal pyramidal. And when you have 2 bonds and 2 lone pairs, the shape is also bent. And you've seen bent before with 2 bonds, 1 lone pair. Sometimes that happens. So if I didn't already address this earlier in class, which I probably should note to myself, the dashed line means that that bond is going away from you, and the filled in line means that it is coming towards you. I'll show you some models during class, hopefully to make that make a little bit more sense. Pause here. All right, I will put the answers on the next slide. So the one on the left, silicon tetrafluoride, that is tetrahedral. The one in the middle, trigonal pyramidal, and the one on the right is bent. As you can see, sometimes there's more than one correct way to answer these. So that there's often, though, more incorrect ways than there are correct ways. So on problem sets, I'm going to be a little bit like on top of you for that. And I will be posting my answer keys so that you can see how I draw things as well. Pause here. Now that I think about it, I think I'm going to post actually a picture with how I draw things when I post this video in like a couple weeks from now. So we're really just going to focus on getting like the notes down. So then we've got our next geometry, which is a trigonal bipyramidal, where you have 5 areas of electron density. The bond angles here are 90, 120, and 180. So how I visualize that in this image here, I have got a trigonal planar with these 3 chlorines, and then above it and below it at a 90-degree angle, I have just a linear. So it's pretty much a trigonal planar and a linear thrown on top of one another. So this chlorine, and this chlorine are all 120 from one another. This chlorine is 90 degrees from all of these 3. This chlorine is 90 degrees from all of these 3. And then this chlorine and this chlorine are 180 degrees from one another. If you have 5 bonds, 0 lone pairs, the shape is trigonal bipyramidal. If you've got 4 bonds and 1 lone pair, the shape is seesaw. When you've got 3 bonds and 2 lone pairs, the shape is T-shaped. It looks like a T. When you have 3 bonds and 2 lone pairs, that actually does not have 120-degree bond angles, just 90, 180. And then when you have 2 bonds and 3 lone pairs, the shape is linear. You only have 180-degree bond angles in that case. Pause here. All right, I'll throw the answers on the next slide. So as a general statement, I don't personally show the angles with the lone pairs, and you don't have to. These are ways that you might see it, but typically I just put the 2 dots there. I'll be posting, when I make the video, I'll be posting my work too, just as a separate image file so that you can see it. But from left to right, we've got trigonal bipyramidal, we have seesaw, we have T-shaped, and we have linear. We're trying to show the bond angles to the best of our ability. Pause here. And then we have our last geometry, that I'm going to expect for you to be familiar with, which is the octahedral. If you're thinking to yourself, octa, that sounds like 8, and there's 6 areas of density, and you'll be totally right to think about that. If I were to actually fill in the one all the way to the left and make it sort of like a 3D shape with faces, it would have 8 faces, and that's where the term octahedral comes from. If you have 6 bonds, no lone pairs, the shape is also octahedral. If you have 5 bonds, 1 lone pair, it's square pyramidal. If you take a look at it, it looks like a pyramid with a square base. If you have 4 bonds and 2 lone pairs, it's square planar. You've got 4 bonds in a plane. If you've got 3 bonds And three lone pairs, the shape is T-shaped. Again, we see a repetition of the word T-shaped. I didn't show it here because I actually couldn't really find any examples of it that exist in real life. But if you have two bonds and four lone pairs, the shape will be linear. Right. I didn't include an example for this just because drawing in a video is really hard and we're going to do tons of practice in class. So I'll just upload a picture that has like all of my drawings. So if you'd like to use it for your notes or really just for reference purposes. All right. Thank you so much for watching and have a great night.